Okay, so we've seen the principles, the counting principles, but in order to actually apply them, actually requires a lot of creativity. So this is not always trivial. Okay, so let's do a whole bunch of examples to try to see kind of the gamut of possibilities. So here's a simple example. I have 3 shirts and 2 shorts. So the question is, how many different outfits, meaning 1 short and a pair of shorts and a shirt, can I actually, count on? How many do I have? So here's the way that I try to kind of organize these things. So what I need is a pair of shorts and a shirt. Okay. So then I ask myself, how many ways can I select the pair of shorts? And the answer is, I have 2 shorts, right? 1 black and 1 yellow. So there's 2 ways to fill that in, okay? And how about the shirts? There are 3 ways to fill that in, right? And so you have to select 1 of each. I'm doing a cross product, so I need to multiply these, and the answer is going to be 6, right? Now, if you want to go through those, then I can think of, oh, I have the black shorts and the yellow shorts, right? And then I have the shirts. So I have, let's see, a blue one, a red one, and a white one, right? And so then how many are there here? There are precisely 6, right? That's kind of the way that we thought of the product principle, right? So this is an application of the product principle. All right. Now let's try a slightly different scenario, okay? Let's say that I, again, have 3 shirts and 2 shorts, but now I have a problem because, you see, I'm going to a boarding school. And in my boarding school, I'm required to have navy blue shorts and light blue shirts. That's it. Okay. So how many outfits do I have? Well, I'll do the same analysis, right? So this is where the shorts go. And then I have shirts. Okay. So how many ways can I pick one of the shorts? And the answer is there's only one way, right? Because I could pick this one or that one, but they're identical, right? So there's only one choice to make. And how many shirts? 1, right? Again, there's only one choice to make. So how many total outfits do I have? Just the 1 outfit, right? Which is exactly what the boarding school wants. So that solves that problem. Not very happily, but that's the solution, okay? Now let's take something a little bit different. Again, I'm going to have 3 shirts and 2 shorts. We're still going to a boarding school. And however, now there's kind of a relaxation about the shirts. So what I can have is, I have shorts and they're both navy blue, so I don't really have a choice on that one. But when I start counting the shirts, I find that I have 2 of them which are light blue and 1 of them which is white. So I actually can pick one of 2 different things here, and I have a total of 2 outfits. Okay, and if you think about it, I have 1 outfit which is the light blue shirt and another outfit which is the white shirt, right? That's my choices. So that's it. Again, I'm using the principle of product, right? But now I have to be very careful because the cardinality of my sets is not 2, for example, for the shorts, because they're identical, right? So I only have 1. That's what's tricky here. Okay, more examples. Okay, let's say that we go to boarding school again, right? But this time we go to a nice progressive boarding school that says, oh, go ahead and pick your own clothes, right? So what we'd like to do is to have a different shirt each day of the week. Okay, we're gonna forget about laundry day. Okay, so we just need 1 pair of shirts for each day of the week. So how many different shirts do we need, right? Now, how am I going to do this? Well, actually, this is kind of like the sum principle or the pigeonhole principle. So what I have is 1, 2, 3, 4, 5, 6, 7 different pigeonholes, right? Because, I have Monday, Tuesday, Wednesday, and so on up to Sunday, right? And for each one of those, I need to put a slot. But now I'm adding them, right? So the answer is 7. Right? I need at least 7 shirts if I want to have a different shirt for each day of the week. Not a big surprise, right? Very intuitive. This particular problem, I think is actually very intuitive. But what we're seeing is an application of the pigeonhole principle, right? I think that's the easiest way to recognize this. I could also argue that it's the sum principle because I'm adding the different days of the week. Notice that they both lead to the same answer. One can, in fact, say that the pigeonhole principle is just a special case of the sum principle, just like we said for multiplication.